If you can get through one more math class, no math for the rest of your life. Okay, it's not going to be that good. But no math for the rest of the week? That's not too bad, is it? This is Thursday. I forgot to tell you guys yesterday, and I apologize for it, although I'm sure you didn't mind. It was on your syllabus, so make sure you keep up with that too, just in case I overlook stating something that I've already put in written form. But the homework was assigned yesterday, okay, and that was Wednesday. So you have 2 class periods, which will be today, but then Monday, it needs to be turned in on Monday. And that's over sections 1, 2, and 3 that we've already studied. But the good news is no new homework outside of what was given yesterday is going to be assigned for the weekend. So we're going to be talking today about geometry. Do you like shapes? I hope so. We're not going to be doing a ton of geometry, but just really just one section of it. If you like geometry, I think you'll like this. Have you ever heard of the Pythagorean, if I can say it, the Pythagorean theorem? That was developed by a gentleman with that base as his name. He was a Greek mathematician. He isn't the one who discovered the formula that we're going to be utilizing today. However, he is the one who's, for whatever reason, his name got attached to it. And so we're going to be talking about the Pythagorean theorem. And I'm going to show you in just a moment. I'll point it out to you. It's a squared plus b squared equals c squared. Have you ever heard about that? Well, we're going to be using it and taking the square root of numbers. And a lot of times you guys will ask me, and a lot of times I wonder too, well, when would we ever use this in life? Well, this is one way that you can use square roots to actually find significant values when you're dealing with right triangles. Okay, if you're measuring a right triangle, you can use a couple of its legs to determine another side, but you're going to have to utilize the square root to do so. Without further ado, let's get right into it. A squared plus b squared equals c squared. Now, here's what that means. In a right triangle, which is a triangle with a 90-degree angle, okay, that's 90 degrees. That, if it were perfectly flat, my arms aren't, but if it were perfectly flat, it's 180 degrees, okay? Perfectly up and down, kind of like the x and y axis on a graph, that's 90 degrees. Same thing with a triangle. This is 90 degrees, and this line that you draw from one base of the leg to the other base of the leg is called a weird word, but it is what it is, hypotenuse. Okay? Hypotenuse. And you'll see in all the problems, I have, well, in 3 of them anyway, I have abbreviated it to hypo with a period. I like that better, don't you? Remember, Joe and everybody else, I'm on your side. So hypo instead of, but the full name of it is hypotenuse. Now, here's where the A, the B, and the C come into play. The A is one leg, and it doesn't have to be just, a certain one every time, but we'll go ahead and say the upright one just to make it easy. The upright one's A, okay? Well, the bottom one is B, the base one, and then the line from B, to the left of B to the top of A, is going to be C, okay? And so in our equation, A is one of the legs, but squared. B is one of the legs, and let's say the base in this instance, but squared, equals, in other words, this one added to that one, the squares of both, equal C, which is the hypotenuse. In other words, it takes all of A and all of B, and both of them squared, to come up with the square of C. And what that tells you is C, or the hypotenuse, is always the longest of the 3 lengths. And that's going to be important whenever we answer numbers 4 and 5. But we're not to that point yet, so let's do these first 3, okay, before we address 4 and 5. Number 1, find the hypotenuse, which is this diagonal line connecting the 2 legs of a right triangle. That's what that means. Find the hypotenuse of A, and I hope this doesn't confuse you in writing that symbol. Please forgive me if it does. I just didn't want to write right triangle with such limited board space. I just didn't have the spots to put it really, and so I just drew the shape of a right triangle, and that's all that that means, okay? Again, if that bothers your brain, I'm sorry, that's my fault, but I did it just to save space on a very small board. So find the hypotenuse of a right triangle with legs of 8 and 15. Guys, here's what I want you to do for practice, even though I know several of you are so sharp, you probably wouldn't have to do it. Please, if you will, for my sake, please do this for practice so that you can learn and get drilled into your mind, in case you don't know already, the Pythagorean theorem. I want you to write the formula each time you're trying to find these answers. And guys, in all seriousness, even yet, when I'm working on pretty tough math problems, if I'm helping someone doing chemistry or physics or something like that, I still, to this day, like to write the formula first of all, each time, so I can refer back to it, and so eventually it comes off of paper and gets drilled into my mind. That's what I've learned is a greatly helpful thing through my however many 20 or whatever years of school or close to it. So that's what I would encourage to do. I'm going to do the formula a squared plus b squared equals c squared. And from there, guys, I'm going to plug in the information that I'm given in the problem. The legs are 8 and 15. Now, in terms of variables, A, B, or C, looking at my diagram up here, what are A and B? Those are not the hypotenuse, that's C. They are the two legs. That's where I want to put this information. Okay, and I did forget a squared right here. Okay, so my legs are 8 and 15. My legs are A and B according to my diagram. And so what I'm going to do is plug in for A the number 8. Okay? Don't forget though to square it, plus what is B? The other leg. Plug in 15 instead of B squared equals, all right, what's C? C is my hypotenuse. Look, do I know what my hypotenuse is? No. Find the hypotenuse or find C of a right triangle. And so I keep not only C as my variable, but also C squared. That is vital. Okay? The first thing I'm going to do is simplify what I find right here. Okay? And what we are going to do with this, okay, just one second, I'm going to go grab my calculator to speed things up, okay? Sorry about that, fellers and gals. I left my calculator in the other room. Guys, get your calculators out too, okay? I want you to use them if you're more comfortable with it. I think you will be. Each of us could do these on paper, but we're going to have some fairly sizable numbers, and so I encourage you, that's okay. On these, go ahead and use your calculators. Okay, what is 8 squared? Remember, that's not 8 times 2. That is 8 times 8. That's what 8 squared means, 8 times itself. And that one we should be able to do in our heads. 8 times 8 is 64. Alright, so I have 8 squared, which is 64, plus 15 squared. I'm just going to put in my calculator 15 times 15, where you can put 15 and put the little 2 above. Again, not times 2, but 15 times 15. And that's 225. Okay? Equals C squared. Now I need to combine by the simple addition. What's 64? I have a two-step equation here. What's 64 plus 225? We can do that in our heads. We can do it on the board. I'm just going to do it fast to save your time, okay? 289 equals C squared. Now, am I trying to find C squared? No, the hypotenuse is measured in C, not C squared. In other words, I have to get rid of that square. Guys, what's the opposite mathematical procedure of a square? That's to take the square root. And so that's how I'm going to end up with C and not C squared. But what I do to one side, I must do to the other side. Okay? And so what I'm going to do right now on my calculator is I'm going to find, I'm going to come up here closer where I think you can see it pretty easily. On my calculator, here's what, and we know that by now, that's what the square root symbol looks like. Can you see that okay? There we go. I think I'm getting it on there a little bit better. And now what I'm going to do is go back to my main screen, which I'm there, and I'm going to punch in the number 289. Okay, the square root of 289 is 17, which means 17 times 17 equals 289. So what is C, or my hypotenuse? It's 17. What do you think? That's not too bad, is it? I know that may be different just because it's the first one probably that most of us has ever done. Or most of us, I should say, have ever done. But it's going to get a lot easier as we move along. Let's do this on number 2. Find the hypotenuse of a right triangle with legs, or in other words, with A and a B of 6 and 7. And I'm trying to find C. Well, the first thing I need to do to avoid any kind of confusion is write my equation, my formula, and this time, how about I do it correctly? I think that'll help a little bit. I left out my squared and the B last time. But A squared plus B squared equals, oh, I can hear your beautiful voices ringing in, C squared. Okay, A squared plus B squared equals C squared. And so what I do from this point is just plug in my information for A and B, my two legs, all right, legs, 6 and 7. That's my A and that's my B, respectively. And I can do it in either order because they're just going to be added in the end, and it's not going to change anything anyway. So for A, I'm going to plug in 6. I'm going to put that in parentheses because I'm plugging it in, and as my formula tells me to do, I will square it. 6 squared plus my other leg is 7 in parentheses squared equals C squared. Okay, guys, we can do these in our heads. These are small enough numbers. They're just the basic multiplication table. 6, remember, not times 2. That's a different thing. But 6 times 6 is 6 squared, which is 36. Plus 7, not times 2, but 7 squared. What's 7 times 7? That's 49. Equals C squared. What is 36 plus 49? What's 36 plus 49? An easy way to do it is take this one down one number to 35 and this one up one number to 50. What's 50 plus 35? That's 85. That's kind of neat, isn't it? Just an easier, simpler way of doing it. You can take one away from the other to get that one up to an even number that we know really well. You've done the same thing. So 85 equals not C, but 85 equals C squared. Just in looking at that, I know it's not going to be a perfect square. And so here's what I'm going to do on my calculator. Let me get it in front of the camera here. There we go. You can see a little bit better. I'm going to find the square root symbol on my calculator, and I'm going to punch in 85, and that gives me an answer of 9 point a whole bunch of junk. I just want one decimal rounded off. So I'm going to do what? 9 point rounded from the 100th to the 10th spot is going to be 2. 9.2. C equals, I know I'm running out of room, sorry, it's a small board, I know, but we're working with what we have, right? C equals 9.2. You might be asking yourself, well, when we're taking the square root of these numbers, why aren't we doing plus or minus like we did yesterday? You remember that? Anytime you take a square root, not only do the plus, but also do the minus. Well, it's different when you're dealing with geometry, and you know every time it has to be a positive number. You're not going to have something that's negative in length. Okay, that doesn't compute in the world of physics. That's not reality. Now, there are some things in which there are negatives that make sense, but the length of something, it doesn't make any sense to have a negative length. The length always has to be a positive number. And so that's not why we're not even considering the negative on these. Okay, number 3. Find the length, listen to this, of a leg of a right triangle with a hypotenuse of 16 and the other leg of 7. Okay, let's underline the significant info we have. The hypotenuse is 16 and one of the legs is 7. Let's write our formula. A squared plus B squared equals C squared. Now let's plug in the important information we have. A hypotenuse of 16. What is hypotenuse in terms of a variable? That's not a or b, it's different this time. Hypotenuse, according to our diagram, is always c, and so I'm going to put the 16 on the right side of the equal sign, but don't forget, put it in parentheses and square it, or it's not going to be the same thing. And one of the legs, okay, we don't know, we'll say we don't know A, since that's the first one mentioned. Find the length of a leg, we don't know what that is. But the other one, the B value, we do know. The other leg is 7. So I'm going to put in parentheses 7, and I'm going to square that. Okay, I need to simplify these two. A squared, can't do anything with that, plus, what is 7 squared? Or what's 7, not times 2, but 7 times itself? 7 times 7. We know that one. Basic multiplication, that's 49. I'll be honest with you and tell you that I don't know I don't know 16 squared off the top of my head. I mean, I could figure it out on the board really quickly, but I'm going to save the time. Okay, let me back up just there. That's a little better. I'm going to save the time, and I'm going to punch in 16 times 16, and that is 256. Now here's another way I could do that. On your calculator, you can too. I could do 16 and go to this screen. I don't know what it would be on your screen. And see that X with a 2, a squared above it. I can hit that 2, or that. See how that turns it into an exponent? And look, same thing as before. I can do it that way, or I can do it just 16 times 16, whichever you prefer. Either way, the answer is the same. 256. So I have a squared plus 49 equals 256. I have a two-step equation, guys, so everything I know is wrong. I want to start with addition and subtraction first. I'm trying to solve for a. I need to move this plus 49 to the right side. What's the opposite operation of plus? It's minus. I subtract 49 from both sides, which gives me a squared equals, what's 256 minus 49? Okay, 16 minus 9 is 7. That's going to turn my 5 into a 4. I'm going to have 0, and I'm going to have a 2. Alright? A squared, not beautifully written. Here, let me rewrite it. Give me just a second here. I don't want to get in such a hurry and get things jumbled that doesn't make any sense. A squared equals 207. Let's make sure that's right. 7, 0, 2. We're good. Okay. I've solved for a squared, or I'm sorry, a squared, but I need to solve for a, not a squared. How do I get rid of, guys, a square that's on a variable? What's the inverse of the opposite operation? Square root. And so I'm going to square root both sides. Okay? And a is going to equal some number. Now again, I'll be honest with you, and I'll tell you off the top of my head, I don't know what that is. It's looking a little better backed up, isn't it? But I'm going to go to the square root symbol on my calculator, and I'm going to punch in 207, just like it is on the board. And look, 14 point rounding to the tenths place using the hundredths would be what? 14.4. Alright? And so 14.4 is going to be the length of the other leg. It needs to be shorter than the hypotenuse, and look, it is. Shorter than that, that's 16. So we're in good shape. Okay, let's do numbers 4 and 5, and then we are donezo. Number 4 is a triangle with sides of 12, 35, and 37. A right triangle is a triangle with sides of 12, 35, and 37. A right triangle. Well, you might look at that and say, I don't know. How in the world am I supposed to be able to tell? Well, you can use the formula. Remember, the formula for a right triangle is right here. A squared plus b squared. In other words, if it's truly a right triangle, I can take this leg and add it to that leg, and it will equal the hypotenuse. Okay? The only thing is, how can I tell what numbers up here are what? The way I can do that hypotenuse is always the shortest? No. Always the middle? No. It's always the longest length because it takes the two legs added together as squares to get to it as a square. And therefore, the longest, guys, 37, has to be my C value because the longest always has to be the hypotenuse, and the hypotenuse is always represented by the variable C. And as far as these go, either one that's remaining can be B or A. It's not going to make any difference because they're added together anyway. And what you do is you take your formula, A squared plus B squared equals C squared, okay? And you plug in those values for each one, and you ask yourself, is it a true statement? Does that one equal that one? So we're going to give it a shot. What do I put in for A? The variable that's been identified as A, 12. And don't forget to square it. Plus, what do I put in for B? The variable that we've identified as B, which is the number, now we know, 35, potentially. Okay, we square that. Equals, in this case, we have all three values. What's left? The variable C, which has to be the hypotenuse, even though it doesn't say 37 is the hypotenuse. We have to know that it is because it's the longest of the three. And the hypotenuse is always that. So, equals 37 squared. Alright? And by the way, 12 squared, we know what that is. Not 12 times 2, but 12 times 12, 12 times itself. We know what that is. Multiplication table. It's a big one. It's the upper end of it. But it's 144. Okay, what we don't know is what these two numbers squared are. And I'm not going to come up there to save time as I've been doing. Do it on your calculator with me though. What is 35 squared? Or in other words, 35 times 35? It is 1225. Okay, 35 squared is 1225. Now we have one more left to do. What's 37 squared? I'm going to take 37 times 37, which is 1369. Now we need to simplify these two sides. Okay? This one's done, this one's not. I need to add 144 plus 1225. 144 plus 1225 is 1369. Equals, rewrite what I had on the other side, already simplified, 1369. Guys, does 1,369 equal 1,369? Yes. Well, that's good. Then that means number 4, check mark, must be a right triangle. Because what we did is we took one of the legs, A, squared it, the second leg, B, 35, squared it, and we set it equal to the hypotenuse, 37 squared, and those numbers do equal each other, therefore it is a right triangle. It's kind of cool, isn't it? Let's do one more of those. Number 5, is a triangle with sides of 8, 12, and 14 a right triangle? Good question. Let's see whether it is that way. Let's start with our formula. A squared plus B squared equals C squared. Do you have it in your brain by this point? You probably, many of you knew it already before, but if not, I think even just by the end of this class, you'll probably never forget what the Pythagorean theorem is. A squared plus B squared equals C squared. All right, what goes where? Well, the only one that's really that important is the largest. Guys, what's the longest length of 3 sides that are supposed to be a right triangle? What's the longest length always? It's the hypotenuse or the C. Therefore, since 14 is the largest value, it has to be the C or the hypotenuse value if this is a right triangle. And these other two, it really doesn't matter in what order we put them. We'll just do them in order of their appearance. Does that sound okay? A and B. A is going to be 8 and B is going to be 12. But we're adding them together, so the order really doesn't matter of those two. The C, the longest, is the one that makes all the difference. Okay, so let's plug in for A. What we identified is 8. 8 squared plus b, which is 12 squared, equals 14 squared. Okay, the first two we can certainly do in our heads. What is 8 squared? 8 times 8 is 64. Plus, what's 12 squared? 12 times 12 is 144. Equals, okay, I'll be honest with you and say, I don't know it off the top of my head. I could do it on a board in probably 7 seconds. But to save that, I'm going to do it in 5 on my calculator instead. 14 times 14, or 14 squared, is 196. Okay, 196. Now what I'm going to do is add these two over here to simplify. 64 plus 144. Again, I can do it in my head. We're just doing it fast in our calculators to speed things up. Is 208. Guys, does 208 equal 196? The answer is no. They do not equal. So is a triangle with sides of 8, 12, and 14 a right triangle? The answer is no. It is not. And as we put a check mark up here, we might as well just write for the one that was, yes, and circle that one. But for the one we just did, 5, no, because 208 does not equal 196. All right, guys, that's all I have. Remember, please feel free to call me, text me, email me, Facebook message me, or even put on the post maybe. Any questions that you have, I'm available during school hours always, and I'm available outside of school hours as much as I'm able to be. I won't be able to get to you probably just immediately if it's outside of school hours, but I will do so shortly. If you have questions, I'm here to help you. I'm on your side. Keep working hard. Things are going to come out absolutely beautifully in the end. But for the weekend, guys, other than just getting your homework done, okay, I want you to relax a little bit. Enjoy the weekend. It's been a different week that we've had, but we're going to keep plugging on. We're going to push right through this, and we will do very well. I assure you of that. I appreciate you guys. Have a lot of fun this weekend. Be safe. We'll see you soon.